ROS, or Robot Operating System, is a standardized and easily expandable robotic framework with plenty of existing libraries that you can use to make any type of robot. In ROS, each part of your robot runs as a node. Nodes are bits of code within the ROS framework to communicate between each other using topics. Let's think of an autonomous vehicle robot. In a vehicle robot, we might have nodes like a LiDAR sensor, a drive controller, and the navigation node. The information published to these topics could be LiDAR scan data, odometry, or command velocities. And with ROS, you don't have to reinvent the wheel. There's already packages that can do these functions. In this example, we can use nav2 and ROS2 control. This modular approach makes it easy to mix and match components from different developers, or even swap hardware, without rewriting everything. ROS also comes with some powerful tools. RViz lets you visualize data in real time, while Gazebo and IsaacSim help you simulate robots before you build them. ROS is also used in research labs, self-driving cars, drones, and even NASA robots. Learning it gives you the foundation to build real-world autonomous systems, from hobby projects to industrial robots. So that's the basics of ROS. One of the best things about ROS is that it's completely open source, built by a global community of researchers, engineers, and hobbyists who share their work freely. There are thousands of ready-made packages, tutorials, and active forums where you can learn, ask questions, and even contribute your own code. When you use ROS, you're not just building a robot, you're joining a worldwide community pushing the boundaries of robotics together.